Section 8.4, rational expressions. Basically, a rational expression is anything like a fraction. We're going to talk about simplifying, multiplying, and dividing. For each one of these three things, there's 2 different examples, and you should have all 6 problems in your notebook. First, simplifying rational expressions. You should be following these 3 steps. Factor, state restrictions, and then simplify. So first, factoring. If I look at the top, I'm looking at 2 numbers that multiply to get 10, but add to get 7. So that would be x plus 2 and x plus 5. That's factoring the top. On bottom, 2 numbers that multiply to get negative 10 and add to get a negative 3. Since this would be negative, my larger number should be negative. So it would be x minus 5 and x plus 2. The factoring will help me state my restrictions, because restriction means whenever you have a fraction, you never want 0 on the bottom. So x minus 5 cannot equal 0, and x plus 2 cannot equal 0. So I actually have to say, what are the 2 numbers that x cannot equal? X cannot equal 5 here, because I have to add to both sides to get x by itself. And x cannot equal negative 2, because I would have to subtract 2. And then I would simplify. So whenever you're simplifying, it has to be multiplying in between 2 polynomials. So you cannot just cross out 5s or 2s if there's adding and subtracting between them. In this case, I have an x plus 2 on both top and bottom. So then my simplified version would be x plus 5 over x minus 5. And I need to have this along with my restrictions for my final answer. Right now, I want you to attempt B. Attempt B by yourself. And then check your work with my work. So your answer would be x plus 4 divided by x minus 3. And your restriction would be x cannot equal 3 or 2. So when you're looking at these and I'm factoring 2 numbers that multiply to get negative 8, add to get a positive 2 is negative 2 and positive 4. 2 numbers to get a positive 6 but add to get negative. If they're adding to get a negative, that means they both have to be negative numbers. For multiplying rational expressions, the same 3 things have to play out. Factor, state restrictions, and simplify. So first, when I'm factoring, the top would be, on the left, would be x plus 3, x minus 2, because that would add together to get a positive 1, multiply to get negative 6. And x minus 5 does not have to be factored, so that's just going to stay as x minus 5. Then I look at my second fraction here. This would be multiply to get negative 25, but add together to get 0. So I have x plus 5, and I would have x minus 5. And on bottom be 2 numbers that multiply to get 3, but add together to get 4. So that's what my factored fractions would look like. Now when I state my restrictions, whenever you have a fraction, the bottom cannot be 0. So in this case, I actually have 3 different restrictions, because nothing on the bottom can be 0. So x minus 5 cannot be 0. X plus 1 cannot be 0. And x plus 3 should not be 0. So my 3 restrictions that I have, x cannot be 5. It also cannot be negative 1. It also cannot be negative 3. And that's how I solve those problems. So now if I simplify, as long as it's the same on top and bottom, they cancel each other out. So it doesn't matter which fraction they're in, they will cancel each other out if it's top and bottom. So here's the x minus 5, that will cancel with this x minus 5. Here's an x plus 3, that will cancel with this x plus 3. There's nothing else on top and bottom that's the same. So my final answer would be x minus 2 times x plus 5. That whole thing over x plus 1. So this would be my final answer. Here I want you to attempt this problem by yourself. If nothing else, try to factor both sets of equations first. So first your factored, you can take out a 2 from the top here. That's how I got that number. For the second one, two numbers that multiply to get negative 16, add to get 0, are going to be positive and negative 4. For my top right side, two numbers that multiply to get 4, add to get 5 would be 4 and 1. And the bottom, two numbers multiplied to get 16, add to get 8 would be 4 and 4. So now I want you to state the restrictions. So again, try to pause the video right now and attempt it by yourself. Your restrictions here would be x cannot equal 4 or negative 4. Now you could write down all of the different equations on the bottom. However, you don't have to. I didn't have to write down a repeat of these three because I'm still going to get a negative 4 for all those three. So I just have to state that once. So now if I look to simplify, x plus 4, here's an x plus 4, so those cancel. Here's the x minus 4, here's an x minus 4, so those cancel. I don't have anything else on top and bottom that's the same, so my answer would be 2, because I have this 2 out in front. I still have to have that on my final answer. X plus 1 is the only thing left up top. And on the bottom, I have an x plus 4, and I have an x plus 4. So this right here would be my final answer. Now, I'm not going to lie to you. Division can be a little bit more tricky. But your first step is always to factor both set of fractions. When you're factoring, you always want to try to get your x variable to be a positive. So I'm going to factor out a negative 1 on top. And I'm also going to write this in standard form. So this would be x minus 2. Because when I took out that negative 1, it changes the sign on the inside. Then on bottom, when I factor this, I'm going to have an x plus 1 times an x plus 1. Because that was multiplied to get 1, add to get 2. And I'm dividing. So on top, two numbers that multiply to get negative 10, add to get 3. Be x plus 5 and x minus 2. And on bottom, when I factor this, I would have an x plus 1, and I'm going to have an x minus 1. So I'm going to do two different things here. I'm first going to state the restrictions. So again, the bottom of the fraction, this cannot be 0 because this is one of my fractions, and this cannot be 0 because this is my other fraction. I'm not going to be writing repeats, so I have an x plus 1 cannot equal 0. I already have an x plus 1. I already wrote x plus 1, so and I also have an x minus 1 cannot equal 0. However, when I'm dividing by a fraction, whenever you have a fraction, divide by a fraction. Just like if I had something like 5/7 divided by 2/3. Dividing by a fraction means you're going to multiply by its reciprocal. So you actually have to write out two sets of restrictions. So I'm going to rewrite this problem right up here, but rewrite it so that it's multiplying by its reciprocal. The first fraction does not change. So I still have my negative 1 times x minus 2 on top, and my x plus 1 times x plus 1 on bottom. But now I'm multiplying, so that means I have to flip-flop the top and bottom. So now on top, I'm going to have x plus 1 and x minus 1. And on bottom, I'm going to have x plus 5 and x minus 2. The reason why I do that after I state my restrictions, because you have to state both the top and the bottom restrictions for your bottom or for your second fraction. Because now I also have that x plus 5 cannot equal 0 because it's on the bottom of this fraction. And x minus 2 cannot equal 0. So if I were to solve all four of these equations, I would get that x cannot equal negative 1 for my first equation, cannot equal a positive 1. It also cannot equal a negative 5 or a positive 2. So those are my restrictions. You have to state all of them. And then you simplify wherever you can. Here's the x minus 2 and x minus 2 on both top and bottom. Here's the x plus 1 and here's an x plus 1. And I don't have anything else to simplify. So I multiply across. So I have a negative 1 on top, so it would be negative 1. I also have an x plus or x minus 1 on top. And on bottom, I have an x plus 1 and I have an x plus 5. So this would be my final answer. So your second fraction, your restriction should always be both the top and bottom. The bottom because this fraction still stands by itself before you do any math to it. And the top because once you flip it because of division, that also cannot be 0 because it would give you a not real number. Right now I want you to attempt this problem by yourself. So first, you should factor both the tops and bottoms, and then state your restrictions. So for my first fraction, the bottom of this cannot equal 0, also be undefined. X plus 4 cannot equal 0, x minus 3 cannot equal 0. But for your second fraction, everything on top and bottom is a restriction. Because before I divide, this right now as a fraction, nothing on bottom should be 0, else make it undefined. But once I actually do the math here, that's what will make this fraction flip. So then the top also cannot be 0. So I would have to write x plus 1 cannot equal 0. X minus 1 cannot equal 0. 2x cannot equal 0. And x minus 6 cannot equal 0. So you're going to have 6 different restrictions here. So my 6 restrictions would be negative 4 from this equation, positive 3, negative 1, 1. This restriction, if I were to solve for x, would be 0 divided by 2, which would just give me 0. X cannot be 0, and 6. So now when I'm going to simplify this, I have my x plus 4. Remember, the first fraction does not change at all. So it's still going to be the same thing on top and bottom for my first fraction. But whenever you're dividing by a fraction, you can always change that to multiply. Then I'll have the 2x on top times x minus 6. And on bottom I'll have the x plus 1 and x minus 1. And this is where you want to see if you can cross anything that's the exact same on both top and bottom. So I have an x plus 4 here. Here's an x plus 4. Here's an x plus 2. Here's an x or plus 1, there's an x plus 1. And nothing else is the same. So then I would have 2x times x minus 6 on top over x minus 3 times x minus 1. So again, you need your restrictions here, and you need your simplified fraction. And that's all I got for you, folks. Make sure you took good notes and have all 6 examples in your notebook. And have a great, grand, wonderful evening.